for day 2 notes, and they are all about rational exponents. And the word rational, that really means fraction exponents. Right? If you can write something as a fraction, you can write it as a ratio. So we're really talking about fraction exponents today. And these notes are going to be no calculator. So do not pull your calculator out. All right, you got to do them by hand. All right, and for these, you want to know the perfect squares, you want to know the cubes, the fourths, the fifths. All right, I think most of us are pretty familiar with our perfect squares. These numbers right here, 1, 4, 9, 16, 100, 121, 144. All right, think what makes a perfect square, all right, is, if 4 squared is 16, all right, the reason why you got to know that is the opposite too. Square root of 16 is 4. All right, the cubes, you want to know these, all right, or at least the first few you should be familiar with, 1, 8, 27, 64. All right, and think the reason you want to know these is you might have to know what the cubed root of 27 is. Think what number can you multiply by itself 3 times to get 27? And the answer is 3. Again, you want to be familiar with the fourths. You don't have to know as many of these because they get pretty big pretty quick. But again, in the notes today, you might be asked, what's the fourth root of 16? And you need to think, okay, what number can I multiply by itself 4 times to get 16? And the answer is 2. All right, and then you also want to know some fifths. You might have to do something like this. The fifth root of 32. All right, you can think, what number can you multiply by itself 5 times to get to 32? And the answer is 2. All right, so those are something to just kind of be familiar with. Squares, fourths, cubes, fifths. All right, so let's look at example 1. It says to simplify. And again, these are no calculator problems. All right, so first thing I would do when you see the fraction exponent, I would try to rewrite it. All right, the denominator in the exponent tells you what root you're taking. You're taking the cubed root of negative 64, and then the numerator 2 tells you what power you're raising it to. And I would do what's in the parentheses first. Think, what's the cubed root of negative 64? What number can you multiply by itself 3 times to get 64? All right, if you're not sure for now, the cubes, well, the cubed root of 64 is 4. Ours is negative 64, so we're going to get negative 4. All right, and you get negative 4 squared. Right, and of course, negative 4 squared is positive 16. It's really negative 4 times negative 4. Double negative turns positive, and 4 times 4 is 16. Let's look at B. All right, in part B, you have a negative exponent. So we really don't want a negative exponent. So what I suggest doing is I would put this over 1 right here. All right, and what you can do is just flip that fraction over. 1 over 243, and then your negative exponent can become a positive exponent to the 4/5. All right, that is a trick there. And now we can do the problem. All right, the denominator tells us what root we're taking. We're taking the 5th root of 1 over 243, and the numerator 4 tells us what power we're raising it to. So here, we can take the 5th root of the numerator and denominator separately. So if you wanted to rewrite this to help you out, 5th root of 1 over the 5th root of 243, we'd still have to raise it all to the 4th power at the end. All right, so really any root of 1, 5th root of 1 is just going to be 1. And then the 5th root of 243, think what number can you multiply by itself 5 times to get 243? If you're not sure, look in your list. 5th root of 243 would be 3. So we'd get 1/3, and we'd still have to raise it to the 4th power. All right, so 1 to the 4th is 1, and think 3 to the 4th. 3 times 3 times 3 times 3. I think 3 times 3 is 9. It's really 9 times 9, or 81. So 1 over 81 would be the answer there. All right, why don't you guys pause the video and take a moment to try the U-try problem. There is a negative right here, so pretty similar to the setup of part B. So press pause, give it a try, and then you can press play and I'll go over it. All right, to get rid of this negative exponent, the easiest way is I would just flip the fraction inside, 27 over 8, and then it would become to the positive 2/3 power. Then you could rewrite it as the cubed root of 27 over 8, all raised to the second power. So cubed root of 27, think what number can you multiply by itself 3 times to get 27? Think it's 3. 3 times 3 is 9, times another 3 is 27. Right? And then the cubed root of 8, think what number can you multiply by itself 3 times to get 8? Think it's 2. 2 times 2 is 4, times 2 is 8. So that's 2, and it's all raised to the second power. So you got to square the top and bottom. 3 squared is 9, and 2 squared is 4. So 9/4 is your final answer. Let's take a look at example 2. It says to simplify. All right, so we need the cubed root of 3,000. So if you don't know that off the top of your head, think how can we break up 3,000? All right, if we go to our perfect cube list, this list right here, all right, think the number 3,000. I don't see it in there, but I do see 1,000, all right, at the bottom. So we could probably break that up into 1,003. So I'm going to break this up, rewrite this, all right, as 1,000 times 3. Hopefully you guys agree that that is 3,000. Then I'll write my x to the 12th. And then I'll write my y to the 14th. All right, so now think cubed root of 1,000. That was in your list. All right, cubed root of 1,000 is 10. So this right here turns into a 10. You can't take the cubed root of 3, so we got to leave that under the cube root. Next, we'll deal with the x to the 12th. Think 3 times what number gets you 12, or 3 goes into 12 how many times? 4 times, so an x to the 4th goes out in front. And then think 3 goes into 14 how many times? All right, or what number could you multiply 3 by to get close to 14 without going over? I think 3 times 4 is 12, so we could do y to the 4th out here. But think 3 times 4 only gets you to 12. We had 14, so there would be 2 y's left over. So a y squared would be left over, and this right here is your final answer. All right, let's look at part B. Part B, all this stuff in parentheses has a negative exponent. We really don't like negative exponents, so I would take that whole term and I would move it to the denominator. All right, and also in the denominator, I see another exponent. So I would take this y term and I would move it to the numerator. That way you can have all positive exponents. And something to point out, the 2x squared, this is okay. No negative exponents there. I would leave that as is. So I'm going to leave the 2x squared where it is. I said we're going to move the whole numerator, all right, that 3x, and it's going to become to the positive second power because we moved it to the denominator. And then the y to the negative 4th is going to be moved up, so it's y to the positive 4th. And now we just have to simplify here. So we've got y to the 4th on top. On the bottom, nothing happens to the 2x squared. All right, but in this parentheses, 3x squared, we got to square both the 3 and the x. So 3 squared is 9, x squared is x squared. All right, and then you could probably multiply 2 times 9 to get 18. So we'd have y to the 4th all over 18. And then x squared times x squared would be x to the 4th. They had the same base x, so we were allowed to add their exponents. 2 and 2 is 4. So this right here is our final answer, y to the 4th all over 18, x to the 4th. Let's look at example 3a. It says to simplify. All right, there's probably 2 ways you could think about doing this. The first way might be to rewrite it, instead of the fraction exponents, rewrite this as the square root of 3, and it would be the square root of 3 raised to the first power times the square root of 3 raised to the fifth power. All right, you really don't need the first power there. But the problem is we don't know the square root of 3. So you kind of get stuck and you can't go any further there. So while that's not wrong, it just doesn't help you to simplify the problem. So what I would do is I would look at it a different way. These both have a base of 3, so you're allowed to add their exponents. So if you do that, the exponents have a common denominator, so you can add the numerators. 1 plus 5 is 6, all over 2, that common denominator. And you guys know what 6 divided by 2 is. 6 divided by 2 is 3. So that would get you 3 to the third power. And think that means 3 times 3 times 3. Or in other words, 3 times 3 is 9, times an extra 3 is 27. So sometimes just a method that you use, it might not work out. So you might just have to choose a different one. All right, so let's look at part B. We can use pretty much the same method. All right, they both have a base of q. All right, but we're dividing here. So you would be allowed to subtract the exponents. So we could rewrite this as q to the 7/4 minus 1/2. All right, and to actually subtract 7/4 minus 1/2, probably want to get a common denominator there. So the common denominator would be 4. So I'd multiply this by 2 over 2. So if we rewrote that, it'd be q to the 7/4 minus 2/4. You have a common denominator, so you can actually subtract. 7 minus 2 is 5. So you'd get q to the 5/4. All right, and that could be an answer, or you could rewrite it as the 4th root of q raised to the 5th power. So really either answer is acceptable. I would just make sure you look at the directions. If sometimes the directions might say that fraction exponents are not allowed, and in that case, you'd want to write it with the 4th root instead. All right, let's take a look at example 4. It says to simplify here, and this one is a little bit tricky, all right, kind of with where that negative is. If that negative isn't in parentheses, all right, the negative is really out in front, all right, so you can almost think of this as negative 16 to the 3/2 power. All right, whatever answer you get, you're just going to kind of put a negative in front of it at the end, since that negative 16 didn't really come in parentheses. So it's going to be negative, all right, square root of 16, all raised to the 3rd power. The square root of 16 is 4. So think 4 to the 3rd power is 4 times 4 times 4. All right, if you think about that, 4 times 4 is 16, times an extra 4 is 64. So you would get an answer of negative 64 right there. All right, where if you look at part B, a little bit different. All right, part B actually came with parentheses. All right, so that means that negative is with that 16. If you were to rewrite it as the square root of negative 16, the negative goes in the square root, and then we're going to raise it to the 3rd power. All right, you guys know you can't take the square root of a negative number, so we really can't get to an answer. We're not going to deal with imaginary numbers in this chapter, so I would just write yourself a note that you can't take the square root of a negative number, and therefore we could say there's no real solution. All right, so those two problems are definitely very different. Simplify. All right, I would rewrite the numerator first as the cubed root of 8, all raised to the 4th power. Then I would rewrite the denominator separately as the cubed root of 27, all raised to the 4th power. And I would treat the numerator and the denominator like two separate problems. All right, think on top, cubed root of 8 is 2, and then we have 2 to the 4th power. On the bottom, cubed root of 27 is 3, so we've got 3 to the 4th power. And think on top, 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. And on the bottom, 3 to the 4th power, 3 times 3 is 9, another 3 times 3 is 9, and 9 times 9 is 81. So we get 16 over 81 for that answer. Let's look at part D. We said the rule is if you have an exponent raised to an exponent, you're allowed to multiply those together. Before I multiply, I would cancel the 3's. There's a 3 on top, a 3 on bottom. So we'd get q to the negative 4/8. And you can reduce that. 4/8 is 1/2. So this is really q to the negative 1/2. All right, and then I'd be thinking, okay, we have a negative exponent. So let's put that in the denominator, 1 over q to the 1/2. And that's about all you can do with it. You could rewrite it as 1 over square root of q. That maybe looks a little bit nicer. This is probably the best answer right there. And then let's look at part E. All right, I would treat those parentheses like two separate problems. Kind of deal with this first, and then the 81 to the negative 1/2 second. They have different bases, so you can't do any adding of the exponents. All right, so the first parenthesis would be the cubed root of negative 27 if we rewrote it. And the second parenthesis, before I rewrite it, we have a negative exponent. So I'd probably put that in the denominator, call it times 1 over 81 to the 1/2 power. And if you have a negative exponent, bring it to the denominator, it becomes positive. And so if we kind of keep working on that, cubed root of negative 27 is negative 3 times, we've got 1 over 81 to the 1/2. That's really the same thing as the square root of 81. All right. This is, of course, over 1 if you want to make them both fractions. All right, so we get negative 3 over 1 times 1 over square root of 81 is 9. So if you multiply your numerators together, you get negative 3. If you multiply your denominators together, you get 9. And if you reduce that, negative 1/3 is your final answer. I hope you guys found these notes helpful. If you have questions, definitely talk to your teacher. Otherwise, you can get started on the day 2 homework. Have a great day.